2.8 Part 1 Function, Operations, and Composition. In this part of 2.8, we'll be focusing on arithmetic operations on functions. Given two functions f and g for all values of x, which both f and g are defined, the functions f plus g, f minus g, f times g, and f divided by g are defined as follows. F plus g is just taking function f and combining like terms with function g by adding. F minus g of x is just taking function f and subtracting off function g. F times g of x is just taking your two functions and finding the product. You can either do that by distributing if there's a monomial, or box method or FOIL. And then we have f divided by g of x. That's just dividing our two functions. Here we note that function g cannot equal 0, or else we would be dividing by 0, which is an undefined situation. In our first example, we're going to evaluate each of these operations on functions by plugging in a number for x. So for example, here we have two functions, function f and function g, and we're going to find f plus g of 1. So another way we can write this from our definitions that we just looked at is going to be f of 1 plus g of 1. So that's what we're doing. We're going to plug 1 into function f, see what we get, plug 1 into function g, see what we get, and then add our answers together. So f of 1, we get out 2, and g of 1, we get out 8. So 2 plus 8 is 10. In the next example, we're going to evaluate f minus g with -3. So again, I can rewrite f minus g of -3 as f of -3 minus g of -3. And now I'm finding f of -3 and g of -3. And then I'm going to subtract my answers. Be really careful whenever we're plugging a negative number in for x and it has an exponent. Make sure that you put parentheses with the exponent on the outside. A common mistake would be to think that that was equal to -9, which it's actually equal to +9. In example C, we're going to have f times g of 5. So that's the same thing as f of 5 times g of 5. We have to find f of 5 first, and then g of 5, and then multiply our two answers together. And then we have f divided by g of 0, which is going to be the same thing as f of 0 divided by g of 0. We need to find f of 0 and g of 0, and then divide our two answers. Make sure to simplify the fraction if you need to. In example 2, we are no longer evaluating for certain values of x, but this time we're just going to leave x in place. So to find f plus g of x, that's the same thing as f of x plus g of x, and we're just going to plug our functions in. So f of x, we're going to put in 2x plus 1, and g of x, we put in x squared minus 4. And then to get our final answer, I just combined like terms. My only like term here was 1 and -4. For part B, we're subtracting. We need to be careful when we subtract because we're going to have to distribute our negative. So I put function f and then function g in parentheses. Now I'm going to distribute the negative and then again combine like terms. Make sure that you write your final answer in standard form, which means decreasing exponent values. Next, we're going to find the product by multiplying function f by function g. We can do this with either the box method or foiling. Make sure in the end that you write your answer in standard form. In this last part of example 2, we're going to be dividing two functions. Now, most times that we divide functions, we're just going to put function f over function g and be done. But the one thing that we always need to watch for is if we can simplify this by factoring either the top or the bottom and seeing if a common factor cancels out. I can't factor 2x plus 1, but I can factor x squared minus 4 to be x plus 2, x minus 2. There's not a common factor on the top and the bottom, so this is just going to be my final answer.